Hello everybody and welcome to the video on type 1 and type 2 error decision matrix. You may see on the homework that we're asking you to reproduce or to draw the decision matrix. What we mean there is the type 1, type 2 decision matrix. Just want to try to get you a quick page number on this. So it may not be that quick. I got to go look it up, but we're looking in chapter 7. No, I believe 7. Let's see. Yeah, page 234. And this is the decision matrix to which I'm referring. Let me see if I can, I'll reproduce it on a piece of paper here on the document camera, and we'll talk about it. But type 1 and type 2 error are real problems that come up from null hypothesis significance testing, or what they call NHST. And we're going to learn about null hypothesis significance testing as we do our inferential statistics here. And so if you've been reading the chapters and looking at the PowerPoint slides, as you should be, then you'll know that we're moving out of we've moved beyond descriptive statistics. We've moved beyond sort of the rationale behind statistics, probability, the normal curve, the assumptions of the normal curve, that kind of stuff. And we're moving into inferential statistics, and we need a way to test certain hypotheses. And so we test what's called the null hypothesis. The null is a statement of no difference or no relationship. And so it's kind of the default that you want to test. And if the test is rejected, so the statement that groups are equal or relationships between variables are not zero, then we might have some actual relationship, or we might have some actual difference that we care about between groups. And so we kind of, most of the time in research, we want to reject the null hypothesis. There are a few cases where we don't, but more often than not, we're going to want to reject that null hypothesis. When we make a decision about the null hypothesis, we make what's called a statistical decision. And we can either reject the null or we can accept it. Now, in actuality, in the real world, there is an actual true nature to the null hypothesis. So let's just say, because t-test compares two different groups, let's just use that as a simple example of this decision matrix. In reality, the two groups may actually be equal to one another on the variable that we're interested in. That would be where the null is actually true in reality. And the other option is that the null could actually be false and the two groups may not be equal to one another. Well, if the actual nature is that the null is true and the two groups are equal to each other, and we reject the null and say the groups are different, then we made an error, right? And that error is called a type 1 error. When we reject the null hypothesis, but the null is actually true, it's called a type 1 error. If we accept the null, so we say we think that the null is true and it actually is true, then we made a correct decision, right? And so that's another cell of the matrix. Well, if we reject the null hypothesis and the null is false, then we also made a correct decision. So sort of 50% of the time, we might make a correct decision, and 50% of the time we're going to be in error. It's just, one of those errors is type 1, the other is type 2. And a type 2 error is when you accept the null hypothesis, you say you think the groups are equal, and they're actually not. So you accept the null, but it's actually false. That's a type 2 error. So let me put this up here, and rather than draw it again, I think I'm just going to put the book up here and try to show you from the textbook. So hopefully it's going to work out okay. Let me see if I can zoom in on this. Okay, so here you're looking at the decision matrix on page 234. And as we said, they have a decision to retain. This would be the decision that you as a researcher make, right? Here over here in reality is the actual state of the null. Either it's true or it's false. We don't ever actually know the true nature of the null hypothesis. So this information, we're not privy to this information. All we can do is make a decision, reject the null, or retain it, which would be accept it. That's the same thing, retain, or reject it. And if we retain the null, meaning we accept the statement of the null hypothesis to be true, and it is true, then we made a correct decision, right? If we reject the null, but the null is true, that's where we made what they call a type 1 error. And type 1 error is rejecting the null when it's actually true. And so you say, like in the example we've been using, you say that there are differences between the groups, and there actually aren't differences, are not differences between the groups. Type 1 error is associated with alpha. So your type 1 error rate is the same thing as your alpha. So if we set alpha, like we're going to do from here on out, we set alpha at 0.05, then we're assuming a 5% risk of making a type 1 error. When we evaluate the null hypothesis, we make our decision, we have sort of a 5% risk of making an incorrect decision. And we're willing to accept a 5% risk. Now, you might say, well, why wouldn't we just accept no risk? Well, we're not perfect beings, and we can never accept no risk. That's not logical. There's always going to be some risk that we're wrong because we don't actually know the state of the null. We don't know the reality of the situation, and we're not all-knowing creatures. We're not gods, so we can't know this information. So there is a possibility that we might be wrong. We might make the wrong decision, and we have to account for that. Now, we can reduce alpha. You saw that with a 99% confidence interval, alpha was set to 0.01. So we could have a 1% risk of making a type 1 error. But every time, the trade-off is if you reduce your alpha to lower your risk of making a type 1 error, then you increase your risk of making a type 2 error. So by lowering your type 1 error rate, you increase your type 2 error rate. And if you lower your type 2 error rate, you increase your type 1 error rate. So, it's like there's a trade-off. It's not just like you could just fix the problem or rig the system. Now, there may be times when making a type 1 error is more egregious. It's worse to make a type 1 error than it is to make a type 2 error. So you may want to reduce your alpha so that you're pretty sure you're not going to make a type 1 error, even though you might open yourself up more to making a type 2 error. And then there's other times where a type 2 error might be the bigger mistake. And so you want to inflate your alpha so that you lower your risk of making a type 2 error. But we'll talk about some of those examples in just a second. Now, just to finish off the table, we've talked about when you accept the null or you retain it and it's actually true, you made a correct decision. When you reject the null and it's true, then you made a type 1 error, and that's associated with alpha. If you accept the null or retain it and it's false, you made another error, but that's called the type 2 error. So when you accept the null and the null is false, or in other words, when you say that the groups are the same and they're actually not, then you made a type 2 error. And then the final one, when you reject the null, you say that there are differences, and there actually are, right? The null is false, you made a correct decision. So that's the table. But rather than memorize the position of these words in the table, know the definition. So that, because what happens is if decision gets moved to here and reality gets moved up here, then the position of these things in the table, they get switched around. So it's much better to know the definitions than it is just to know where they're located in the table. And don't put it past me to switch them up on you on the test to keep you on your toes, because I want you to know the definitions. I think it's important. Now, let's talk, just to wrap this video up, let's talk about an example where type 1 error might be worse to make than a type 2. Let's say that you're a researcher and you're tasked with trying to determine if there are differences in intelligence based on race. And so you have two groups. Let's just say, to keep it simple, you have your white individuals and your black individuals. And you're testing to see if there are differences in intelligence based on that racial category. And let's say that you make a decision to reject the null and say, yes, there is a difference in intelligence based on race, but in reality, there actually is not. Then you made a type 1 error. And let me tell you something, that example, because this has happened, right? This is sad reality, is that there is this, that people have for many years in the past, and even some current, even though things are getting better currently, there may be some people that still believe that there is a difference in intelligence based on race. And so it's kind of like what resources get given or allocated to one race versus another are different because of this, sort of false information. And so it would be a really bad mistake to make a type 1 error in this situation and say, yeah, I think there's a difference in intelligence based on race, when there's not actually one. So what we might want to do in that situation is we might want to lower our alpha so that we're pretty sure we're not going to make that type 1 error, even though it opens ourselves up to making the type 2 error, which is when we would say, so when we're more likely to make a type 2 error, which would mean that we're more likely to say that the groups are equal on intelligence, regardless of race, even if they're actually different. And I think, though, the bigger mistake would be to conclude that there is some kind of difference in intelligence based on race than there would be to say that there's no difference, even if there was. It's kind of like, and we've seen that sad story sort of played out in reality where, resources get divided among the races, and they're divided disproportionately because there's this sort of bad science or this myth out there that there's somehow differences in intelligence or intelligence trajectories based on race. And that stems way back to class class systems and trying to keep certain individuals in lower classes. It's a sad part of our history. But that's a type 1 error where it'd be a bad mistake to make. Now, type 2 error, let's talk about an example where it'd be a bad mistake to make a type 2 error, right? Let's say that we're a researcher and we're tasked with this, we have two groups again, and we're tasked with the job of determining if smoking crack is actually bad for your brain. So, what we're trying to determine is, do people who smoke crack, do they have the same level of intelligence as people, do they have the same sort of mental capacity after smoking crack as people that don't, right? And so let's say that we accept the null hypothesis and say that there is no difference in mental capacity or intelligence based on whether you smoke crack or not. So honestly, what we're kind of saying is, it doesn't matter if you smoke crack or not, you're going to be just as well off sort of mentally or cognitively, regardless of whether you smoke crack. Well, if we retain the null and say there's no difference, and in reality, sort of we retain the null, but in reality, the null is false, and there is a difference between people who smoke crack and people who don't, then we've made a type 2 error, and that's a pretty bad one to make too. So it's kind of like, crack's okay. Just, smoke as much as you want. It's not going to hurt you. And then come to find out, oops, it's kind of a bad thing. So more of a mistake to make a type 2 error. So we might want to increase alpha, like inflate alpha, make it higher so that we decrease our risk of making a type 2 error. Even though by decreasing our risk of making a type 2 error, we're going to increase our risk of making that type 1 error, which is when we reject the null, say there is a difference between the two groups, smoke crack, don't, when there actually isn't. So, if for some reason, like this would never happen, right? But if crack really wasn't bad for you, and we said, oh, we think crack's bad for you, so you shouldn't smoke it, and it actually wasn't, well, that's a mistake, but that's a mistake we can live with, versus like saying, oh, well, crack is bad for you, or crack's not bad for you, so have as much as you want, and then come to find out, oh, you're addicted, and now you're having problems. So, the type 2 error is probably more egregious in that situation. So that's a little bit about the decision matrix. When you're filling it out, just repeat this table in your homework, but I want you to know the definitions because you're going to be tested on them. So that's it. Thanks.